Hi grade 7s, today we are doing our last lesson in chapter 5 and we're looking at turning fractions into decimals. Last time you looked at turning decimals into fractions, this time we are going to go the other way around. So let's start with this example here. Lighthouses. At one time, 31 out of 50 lighthouses of the 50 states in the United States had lighthouses. This can be written as a fraction of 30 over 50. How can you write this fraction as a decimal? Well, like we have looked at before, anytime you have a fraction, really it is saying we're dividing the numbers. So if I have 31 over 50, it's the same as me saying 31 split into 50 parts, or it's 31 divided by 50. So we all know how to do that. Let's try it out. If we have 31 divided by 50, well, 50 doesn't go into 31, so now we have to move into the next place. Remember, there's a decimal here, so we move our decimal up, and then we add a 0 in the front. So how many times does 50 go into 31? Well, 50 goes into 306 times. And I am left with 10. I add another 0. Now I'm in my 100th place. And 50 goes into 100 2 times, and I have 0 over here. So that means 31 over 50 as a fraction is written as 0.62 as a decimal. All I have done is simply divide a 31 by 50. So maybe for your notebook, writing a fraction as a decimal is simple as saying you divide the numerator by the denominator. So, in other words, if I had the numbers 1 over 4, well, 1 over 4 means 1 divided by 4. And if I were to use algebra, then I have A over B, and this simply means A divided by B. So let's use some words here. To use words, it would be to write a fraction as a decimal. I hope you're writing with me. Divide the numerator by the denominator. So we have our numerator here, numerator, divided by, let's choose blue for denominator. There we go. Okay? So if it helps, you can always write it out in this form first before you move it into division. Before you move it into 1 divided by 4. Or again, you can think of it as how many parts are you splitting it into. 1 over 4 is 1/4, which means you're splitting a whole into 4 parts. Now I'd like you guys to try it yourself. So pause this video and try these 4 questions. The answer will appear in 3, 2, and 1. Are you ready? Check your answers and see if this is what you got. Now, when I say show your work, make sure you're actually showing your work in your homework. In your homework questions, if you're asked a question like this, make sure you actually write down the original fraction that it is equivalent to. Okay, so let's move on to another example here. This time, let's look at using turning a mixed number into a decimal. So excuse me for my drawing of what seems like a deer, but our question goes, a deer has an antler spread of 15 and 2 over 5 inches. So this here, measured length, is 15 and 2 over 5 inches. Write this as a decimal. You can pause this video and think for a second, how might I turn that into a decimal using what I just learned? Well, based on what you already know about fractions, 15 and 2 over 5 really has two parts. It is the 15 as a whole and 2 over 5 as a fraction. So I really don't have to do anything with the 15. What I do have to figure out is what 2 over 5 is as a fraction. So we just did this earlier. 2 over 5 as a fraction would be 2 divided by 5. So try it out. What do you get? So you should have found that 2 divided by 5 gives us 0.4. So 2 over 5 equals 2 divided by 5, which gives us 0.4. So now what I really have is 15 plus 0.4. So that gives me 15.4. If I want the measurement of the antlers spread, of the deer's antlers spread in inches, then I have 15.4 inches. So what can we write in our notes to help us split up the steps? First thing you want to do is leave out the whole number and then convert the fraction into a decimal. Step 2, add the decimal to the whole number. So let's try a little more challenging of an example. Write 2 and 21 over 25 as a decimal. You can pause this video and try it out yourself right now. So 2 and 21 over 25 is just 2 as a whole number along with a very large fraction. So how can we turn this fraction into a decimal? Well, I take 21, split that into 25 parts, so 21 divided by 25. Well, I know 25 fits into 21 0 times, so I put a 0 there. And then I want to add another 0 here. How many times does 25 go into 210? Well, 25 goes into 200 8 times. Now I'm left with 100 here. And 25 goes into 100 4 times. That's it, I'm done. It looks like a large number, but it's actually a lot easier than it looks. So now I can change this into 2 plus 0.84, 2.84. Move this down here. I will write my final answer as 2 and 21 over 25 equals 2.84. So here's something interesting. The number 2.84 as a decimal is what we would call a terminating decimal. That's because that when I divide it, at some point I stop at 0 and there's no more numbers that could possibly go after that except more zeros. So I have a final digit and that's what makes it a terminating decimal. We also have occasions where the decimal doesn't ever terminate and we just have to keep on dividing. Or maybe we can shorten that. For example, 0.33333 and so on and so forth. That is not a terminating decimal. We call this a repeating decimal. And instead of writing all those 3's, this is written as 0.3 with a little bar on top. Another example, I can have 2 digits that repeat. I could have 0.01010101 ... Do you see the repeating pattern? If you said the repetition is in 0, 1, you're correct. So I will write this as 0.01 with the bar across both 0 and 1. I can even have 3 digits that repeat. For example, 0.4205 205 ... Okay, so where is the repetition in here? Well, it doesn't start at 4. Instead, it starts at 205 and then another 205. So when I write this decimal, I write 0.4 and then I write my repetition of 205. And my bar on top, you guessed it right, I only write it over 2, 0, and 5. A decimal is called a terminating decimal when it has a final digit. So that means it has an end. A decimal is called a repeating decimal when one or more non-zero digits. So it can't just be, well, 0.400000. That doesn't count. That would just be a terminating decimal, right? So when one or more non-zero digits, it doesn't just repeat once or twice or 3 times, but it repeats forever. And we like to denote that repetition with a bar on top. So why don't we look at some fractions that are actually repeating decimals? First, let's write 7/6 as a decimal. 7/6 is basically saying 7 divided by 6, or 7 split into 6 parts. So I could write it like this. 7 divided by 6. And then let's work that out. Well, 6 can go into 7 exactly 1 time. I am left with 1. I move down with 0, and now I have a decimal place here. 6 goes into 10 exactly 1 time. Now I have 4. I have another 0. 6 times 6 gives me 36. That gives me 4 again and a 0, and then I do another 6. I have 36. Okay, so are you starting to see this pattern here? This is only going to continue. So instead of keeping going, I can simply stop here as I know that this is going to repeat. And I will write my answer as 7/6 equals 1.16. Only once, but I put a bar on top. Okay? That's it. So why don't we try another example, and this time I would like you again to pause the video and write this out. Write 1 and 5/33 as a decimal. So now we're putting together a few things we learned today. The first thing I want to do, step 1. I need to remove the 1 and 1. I'm going to leave it as that. And I'm going to leave it as plus 55 over, not 55, 5/33. Now I have to convert this into a fraction. I want to convert this not into a fraction, but into a decimal. So let's do that. It's essentially saying 5 divided by 33. I'm going to write that out here. 5 divided by 33. Well, 33 definitely doesn't fit into 5, so I put a 0 here. 33 fits into 50. And 50 minus 33 gives us 17. So I make that 170. 5 of these fits into 170. I get 5 times 33. Gives me 165. And then I have another 5 left. So I go into 50. So far it's not repeating yet. Now I have 50. How many fits into this? Oh, I see the repetition. Or rather, I hope you see the repetition. 170. And then I have another 5, 165. So on and so forth. So when you get to a point like this, maybe some of you guys already saw the repetition when we did this. But we don't know for sure that it's a 2-digit repetition until you do your next step, okay? So always make sure you confirm your 2-digit repetition first. So now I know 5 divided by 33 is 0.15 with a bar on top. And don't forget your whole number that you started off with. So I can rewrite my fraction. I'm going to move up here. Step 2. What was my step 2? Well, it was to add the decimal to the whole number. So now I can take my 1 plus 0.15 bar, which gives me 1.15 bar. So I can say that 1 and 5 over 33 equals 1.5 repeating. Sorry, 1.15 repeating. Okay, let's just try a few more examples before I let you guys go off here. Write the following fractions or mixed numbers as a decimal. I'd like you guys to add this to the top of your homework, or just take a picture of your class notes where you have done these examples so I can see how you did them. Now you can pause this video and I will show you the answers. Are you ready for the answers? They're going to show up in 3, 2, and 1. Here we are. So for the first question, I split up my 5 and 2 over 5. Then I look at what is 2 over 5 as a decimal. So I divided 2 into 5 parts, and that will give me 0.4. So I add 0.4 to 5, and that gives us 5.4 as our final answer. For the second fraction, the first thing I want to do is the same. I split up 3 and 5 over 8. Then I go ahead and do 5 divided by 8. And I get 0.625. So 3 over 5 equals 3.625. For question number 7, we don't have a whole number this time, so we go ahead and do our division of 2 divided by 3. I'm moving to my decimal places right away, 0.66. And 6 is a repeating number, so I have that right here. 2 over 3 equals 0.6. Last but not least, we have 3 and 2 over 11. So I have here 2 divided into 11 parts, and I find the repeating decimals 0.1818. I add that back to my whole number of 3 over here. So 3 and 2 over 11 gives me 3.18. So that is it for today. I will post your homework questions with your lesson on top here, as well as under where it says homework for 5.8. Okay, so for homework 5.8, I've also added a picture of these lizards here because I'm not sure if you guys can see the pictures in your booklet very clearly. Anytime you have questions that you can't see very well in your booklet, go ahead and pull up your class pages where you can download the PDF for all of chapter 5, okay? Let me know if you have any questions, and that is it for today.